Okay, before I go on with the rationals, there's two things that I would like to demonstrate for you. The first one, let's go back to this problem right here. If you remember this problem, when we solved it, it went from -1 to 3 and had these curved brackets. I want to combine this with your existing knowledge of what a quadratic equation looks like on the Cartesian coordinate system. Okay, so this right here we know is an upwards parabola. So if I were to graph this, and I already know my critical numbers are at -1 and 3. Well, it turns out that this graph of a parabola looks like this. Now when you combine that with this, you're looking at where is that graph less than 0. Okay, well, less than 0 is going to be everything under the x-axis. So this whole thing is where that formula is less than 0. And just like we showed right here, it's less than 0 from -1 to 3. So this ties in to what you already know about graphing quadratics. And at no point in time did I intentionally make this look like somebody's face. Even though I'm sure that's what you guys are all looking like while we go through these inequalities, because doggone it, they're a lot of fun. Anyways, let's talk about rationals. Rationals are solved in a similar manner that we did the polynomial ones. Okay, the only difference is this time our critical numbers aren't going to be what it turns out to factor into, because we have a numerator and a denominator. Our critical numbers end up being determined based on the 0 both in the numerator and in the denominator. Hopefully that made sense. If it doesn't, it'll certainly clear up as we go through this problem right now. Okay, so first of all, we got a problem. We got that 3 over there. So we're going to need to move it to the other side. And again, we have a problem because we have a fraction and a non-fraction. In order to combine those two, we're going to need a common denominator. That common denominator is going to be, of course, x minus 5. So I'm going to multiply by, not what I wanted to do, x minus 5 over x minus 5. And I'm going to end up with 2x minus 7 minus 3x minus 15 all over x minus 5. 2x minus 3x is a negative x. Negative 7 minus a negative 15 is 8. So that's what that simplifies to. We want it less than or equal to 0. Our critical numbers are determined from the zeros in the numerator and the denominator. So our critical numbers are 8 and 5. Alright, I'm going to get some stuff out of the way here. And I don't feel like filling in this number line. I just know that I have critical numbers at 8 and 5. Alright, so I'm going to test the first region. I'm going to use the easiest number, which is 0. Second region, I might as well use 6, and the last region I might as well use 9. Okay, when I plug 0 in, and again, it's probably easiest just to use the original equation. Cancels there and there. I'm left with a negative 7 over negative 5, which is 7/5. Is 7/5 less than 3? Yes. Okay, because 10/5 or 15/5 is 3. We only have 7 of them, so this zone works. If I plug a 6 in, now I'm going to come back down here. I have a 14 in the numerator. I'm sorry. I have a 2 in the numerator. And in the denominator I have a 1, which is positive. Positive is not less than 0, so that region does not work. When I plug a 9 in, I have a negative 1 in the numerator, and I have a 4 in the denominator. That is a negative number, and negative is less than 0, so yes to that zone. Alright, so I didn't want to get rid of that. Let's try this again. I want that. My zeros, or my correct regions, are going to go from, do I use a curved bracket there, or do I use a hard bracket? Right there, it's a less than or equals to, so I actually use a hard bracket. Is that right? Is that a hard bracket? Well, is it okay to use exactly 5 in this equation? Actually, it's not, because if I use 5, I divide by a 0. So in addition to making all your normal checks, which is looking at whether or not that's a less than or equals to, or vice versa, you also have to look at the denominator and make sure that you're not including a value that will result in a 0 in the denominator. So having a curved bracket there is correct, and it's everything over here. And for the 8, that is a hard bracket, and everything this way. So my answer is negative infinity to 5, or 8 to infinity. Okay, so I want to emphasize again, we already know that we look at that greater than sign to determine whether or not it has that equals in it, to determine whether or not we have a hard or soft bracket. Beyond that, we need to check the denominator to make sure that we don't use a hard bracket when the denominator is 0. So keep that in mind as we go through these. Alright. Try this one on your own, gang. Okay, that's how it factors out. My critical numbers. Are 1 and 3. So, drawing my number line, my critical zones would be here and here. So I'm going to try 0. Always a wise choice. I'm going to try 2. And I'm going to try 4. 0, I'm going to come right back up here because it's easiest to try right there. That's gone, that's gone. Is 5/3 less than or equal to 1? No. When I try 2, then I'm going to come back here. I have a 2 times, well, forget the 2. I have a 2 minus 1, so I have a 1 on top. And a 2 minus 3, I have a negative 1 there. That gives me a negative number. That's what I want. So that zone is yes. So I got a no over here and a yes right there. Plug 4 in. I have a positive on top and a positive on bottom, which is positive, which is not less than 0. So no. So my critical zones, and remember 3 cannot be a hard bracket. So I'm going from 1 inclusive to 3 non-inclusive. Alright, hopefully that makes sense to you. And of course we would have hard bracket there, soft bracket there, like that. Okay, I want to go over one last thing, and that is an example where you get something that is probably not quite expected. For example, you want to know where is it that x squared plus 2x plus 4 is greater than 0. So you first want to factor it, and yeah, that's going to be a bit of a problem. So what we want to do is find our zeros. We would jump in and use a quadratic formula. Negative b plus or minus b squared minus 4ac all over 2a, and right away we notice we're going to have an I right there. Oh boy, what does that mean graphically? Graphically it means there's no zeros. Okay, we can work with that because we know that this is a quadratic that opens up. If it opens up and yet it has no zeros, that means the x-axis is down there. So where is this particular graph greater than 0? Everywhere. So what would our solution be? Our solution would be all reals. Okay, the same exact thing could happen the other way. If instead of being a positive or a greater than 0, if that were a less than 0, well then there would be no possible answers. Let's try this again. Okay, so there would be no solution in that case. And that's it. See you in class.